So finding the divisibility of the number have two ways. Either we divide the each number, or when we go for further longer conversions and divisions like LCM and HCF on a higher level, we need to know some tricks or hacks. That's also called the test of divisibility. Like we can check if the number is divisible to a certain number by just looking at it or solving it in a easier way rather than we have to redivide the whole number. So I have the few numbers and how to check if they are divisible by it or not. We'll have some hacks, and after that, I'll in the end we'll do two, three examples to give you the idea of the thing. Let's start with two. We will discuss two, three, 4, and 5. So the 2 1 is like quite easy one. You have to check for the even numbers at the end in unit place. You have to check in if the number is 0 or 2 or 4 or 6 or 8. If the number at the unit place is any of these numbers, then the whole number is divisible by it. Let's say you have number 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, and 6. Only just the n number is even, it means the whole number is divisible by 2. Wouldn't it make our work very easier? Of course. Now for the 3, you have to take sum of digits. I'll explain you each by the example. It would be, I think, more better approach. Sum of digits. If the sum of the digits is a number divisible by 3, then the whole number is also divisible by 3. For the 4, we choose two last digits. If last two digits are divisible by 4, then the whole number is also divisible by 4. And for the 5, it's quite easier for the 5 too. At the unit place, again, we check for either a 0 or a 5. Now I'll give you an examples for each of this. 2, let's say 2, 4, 6, 8. And another example is 1, 5, 6, 7, 3, 1, 1, 9, 3, 6, 3. For 4, we have 1, 4, 1, 6, and then 2, 4, 3, 1. 5, we'll take the example of 1, 5, 0, 5, and then 1, 0, 0, 1. Now let me tell you which one is divisible and which one is not divisible. Say the unit place has one of the even numbers, so it means number is divisible. The unit place does not have any of these numbers, it means it is not divisible. Sum of the digits 1 plus 1 plus 9 equals 11, which is not divisible by 3, so means this number is not divisible by 3. For the next, we have 3 plus 6 plus 3, which is equals to 12, which is divisible by 3, which means this number is divisible by 3. For next, we have 16 in the end. 16 is divisible by 4, which means this whole number is divisible by 4. In this, last two digits are 31, which are not divisible by 4, so this number is not divisible by 4. It ends with a 5 in unit place, which means it is divisible by 5, and then this one ends with a 1, that means it is not divisible by the 5. You're seeing how much easier our work is in that way. It is so easier to do, and with this, we can just solve it in the minutes, in the matter of minutes. For the next four numbers, I would go with 6, 8, 9, and 10. 6 is quite simple. You can remember it by this trick that 2 multiplied 3 equals to 6. So it follows the rules of 2 and 3. A number that follows the divisibility, that passes the divisibility test for 2 and 3 both, is also divisible to the 6. We'll be dealing with an example to give you a better idea. Moving on next, for the 8, last 3 digits. Last 3 digits should be divisible to the 8 to see if the whole number is divisible to 8 or not. For 9, we see the sum of digits. This one is similar to the 3 one. In 3, we see the sum of digits is divisible by 3. In 9, we see sum of the digits is divisible by 9. And in the 10, digit in unit place is 0. Let's move further with the examples. For the 2 one, let's go with this. 9. Let's check. So firstly, we are going to check if it is divisible by 2 or not. It ends in even number, so means a 1 take. And the sum of these numbers, what would be the sum of 2, 3, and 4? We're going to check that. 2 plus 3 plus 4. Sorry. 2 plus 3 plus 4 equals to 14, which is not divisible by 3. So this whole number is not divisible by 3. Let me check again. Sorry, I think I made a mistake. 2 plus 3 plus 4. It's equals to 9. This means this is divisible by 3 as well. So if it gives the both tick, that means it is divisible to 6 as well. For next we have even number, means it gives a 1 tick. However, if we add the number 1 plus 6 plus 0, it gives 7, which is not divisible by 3. So this number as a whole is not divisible by 6. For the 8, let's check the last 3 numbers. 418 here. 418 divisible by 8. It's not. This number would be not divisible to the 8. I'm using a calculator. You have to, depending upon your grade, you can use calculator or you can just use a rough book. 198 is it is divisible by 8 or not? No, it is not divisible to 8. So this number is not divisible to 8 as well. 119. Let's add these numbers and let's say if they are divisible to 9 or not. 1 plus 1 plus 9 equals to 11, which is definitely not divisible to 9. Moving on, next we have 5 plus 4 plus 3 plus 6 plus 9 equals to 27. Is it divisible by 9? Yes, it is. So this whole number is divisible to 9 as well. Here it ends in 0, which means this is divisible by 10, and it ends in 1, which means it is not divisible by 10. Next, I have two more numbers. for you, one being 11 and the other being 25. So the 11th one is we take the sum of alternate digits. First step is this. It's going to be a bit complicated. Sum of alternate digits. What are alternate digits? Let's suppose you have like even numbers in one and odd numbers in one, index of even numbers and odd numbers. This and this would be on one, and then this is in would be another group. So we'll take this two groups of alternated digits, even and odd indexes, and we'll take the sum of it, and then we make difference of these groups. Like we subtract these groups. Difference. Both groups. And the last way to check is it should be either 0 or multiple of 11. The difference. For 25, last two digits should be divisible by 25. Quite similar to the 4. Let's take some examples so we get a better understanding of the subject. For 11, let's go with 1661. And the next would be 103081. And for the 25, we would go away with 1025 and then 1050. I'll solve this 25 one first. Last number is 25, which is divisible to 25. So this whole number is divisible to. Last number is 50, which is divisible to 25. So this number is divisible to 25 as well. Now let's go with this 11 one example. 1161 and 10381. Let's do this here. 1661. 1661. Alternate digits. 1 goes here and then 6 goes here. Then this 6 would go here while the other, this one would go here. These are the alternate digits. This form a 7, now this form a 7 too. This, now the sum of 7, the difference of 7 minus 7, it would be equals to 0. So it should be either 0 or multiple 11. This means this number is divisible. Moving on, next we have 10381. So we have 10381. 1 goes here, 0 goes here, 3 goes here, 8 goes here, while 1 goes here. 1 plus 3 plus 1, it would be equal to 5. Well, 0 plus 8, it's 8. Now, the difference is 8 minus 5, which is not which is equals to 3. It's not a multiple of 11 or a 0. So this means this number is not, oh, there's a 1 too. Oh, if I got 103081. It's 103081. 1 goes here, 0 goes here, 3 here. This means, let me just rewind it. Sorry, 31030. And the 8 goes here. Now the 1 goes here. 8, 3, and 1. It would be equal to 12. Well, this side, it would be equal to 1. 12 minus 1 is 11, which is a multiple of 11, which means this number is divisible by 11. So that's we are testing. These are the rule of divisibility. We looked for the 10 different numbers and how to check their divisibility. And further on, we will be moving towards prime factorization, and then we will go towards HCF and LCM in quite detail. Thank you so much.